So welcome to our revisions as I try to answer some questions. So we are looking at A3 from the 2024 5070 paper 2. It says elements react together to produce stable compounds. Draw the structures of the following compound using dot and cross diagram. So they have given you for ethene, then they want you to show all electrons. So you can put up a key there. And what is the key there representing? I can simply say the cross, let them represent electrons of carbon, and the dots represent electrons of hydrogen. So you start by writing the electronic configuration. Carbon is 6, so the electronic configuration will be 2, 4, and hydrogen is 1, so the electronic configuration is just 1. So now when you are drawing this one, this is ethene. So if you are in grade 12, you have the knowledge of organic chemistry. You remember that ethene, this homologous series, they contain a double bond between the carbon atoms. So what are we going to do there? So if I have, in this case, carbon there will be another carbon that I'm going to have. But inside, there will be, so this is carbon and that's carbon. Carbon is representing, the crosses, so the inner energy level is that. And since they have a double bond, it means it will put up 2, and this one will also put up 2 electrons. Then the hydrogen that are 4 will get attached to these ones. Remember, there will be hydrogen there will be another hydrogen there, hydrogen will attach there, and hydrogen will also attach the other side. So when hydrogen puts up, this one will put up, that one puts up, it will put up, carbon puts up, hydrogen puts up there. Then the same thing is going to happen there. So this is actually the structure that you needed to draw. In other words, the structure looks something like this. The structure looks something like this, where the dashes that I'm drawing are representing the number of bonds that are existing. So between carbon and carbon, there's a double bond. So remember 1, 2, there are 2 pairs there. So that's a double bond. Then carbon is tetravalent. So this carbon should have 4 bonds, 1, 2, 3, 4. And that's why we have attached the 2 hydrogen. And of course, even this side, the same thing should actually happen. So this is a structural way of representing, ethene that we have there. Obviously, I know if you are still in grade 10, 11, you may not fully understand that, but when you do organic chemistry, you appreciate, what we have just done there. All right, then the B part says lithium oxide shows, they want us to show the structure of lithium oxide, then show outer shell electrons only. So we're just showing outer electrons only, which is actually good on our part. So let me just pick up a periodic table so that we can actually get to use it. So lithium has got proton number 3, so the electronic configuration will be 2, 1. Then oxygen has proton number 8, so the electronic configuration will be 2, 6. And the key there, we need to put up a key. Let me say the cross represent electrons of oxygen and the dot electrons of lithium. It doesn't matter, it's up to you to actually choose which one is actually workable for you. There are no rules as to what you do. So since they want us to show the outermost shell in this case, so what is going to happen, remember, this is between a metal and a non-metal, so this is an ionic bond. So because if you look at lithium oxide, lithium has a valence of 1, oxygen has a valence of 2. So when you exchange the valences, you are going to find lithium oxide will be that. So there are 2 atoms of lithium. Each of them will give 1 electron to the oxygen. Yeah, so there are 2 of them. So remember, this one forms up a positive and that one forms up a negative charge. So what we can do is that we can actually say, if this is lithium, in this case, it has got how many? When it gives out, it will remain with 2 in this case. So you are going to have 2 electrons, but it would have actually given out 1. Then I'm going to put up in this case, the oxygen. So oxygen has got how many in the outermost shell? So it had initially 1, it had 1, 2, 3, 4, 5, 6. So it will gain 2 in this case. Remember there are 2 lithium, so you put up another one. Oxygen has gained 2, so it will have a 2 minus. Then this side I'm going to have another lithium with the, the 2 electrons in the outermost shell. Then it will have a plus there. All right, remember I've drawn it like that so that you can actually see. I know one would have just put a 2 here instead of including that. One would have actually just put a 2 there. It's another way you could have actually done it, of course, but I want to show that. Remember, like charges attract, like charges repel, and like charges attract. So you need to know how to actually place them there. So this is what you needed to do there. Then C says, explain why ethene does not conduct electricity in any form while molten lithium oxide does. So they want, why does it not conduct electricity? So I can simply say that, ethene, is a covalent. So I can say is a covalent, compound with no free, ions or delocalized electrons. So that's the idea. So ethene is a covalent compound with no free ions or delocalized electrons. Hence it does not conduct electricity in any form. While lithium, we can simply say lithium oxide is an ionic compound, with, so of course in its solid states I can simply say it's an ionic compound with free ions, or if you want you could have said delocalized electrons, and hence conducts electricity. Now you think, this answer is too long. What you could have just said is that ethene has got no free electrons or delocalized electrons, hence it doesn't conduct. Lithium has free ions or delocalized electrons and hence conducts electricity. So that is what you could have said in order for you to answer such a question. Thank you so much for watching. If you love what we do, please subscribe to our channel and share so that others can actually get to learn.